Alright, howdy and welcome to my video where I will be going over exam 1 for Reveille, and this is the summer 2024 edition, right? So I'm just going for this exam. I'm going to talk about different strategies, different approaches, and what I think the fastest, most straightforward way is, and I'll talk about alternate solutions and um, maybe some tips and tricks and ways to avoid some common pitfalls that these questions present. All right. So the first question we see here asks us to use exponent rules to simplify the following. Right. So we're not solving for anything. We're not just factoring or whatnot. We're just combining stuff together, and we can only use positive exponents. That means if I have a negative exponent, I need to use the negative exponent law to move it to the other side of the fraction bar, right? So to write it out, this right here means I have a negative x, I have 1 over ax, or if I have 1 over negative ax, I get a power x, all right? So let's start. And first thing we'll notice is that I have two terms that may multiply each other. So I am most likely going to, and I will, combine both terms into one, right, using the multiplication law. And I will also note that these terms have an exponent outside. So I need at some point, I need to distribute these exponents to their respective terms. All right. So we're going off Hedma's, right? We need to do exponents first. So we're going to distribute first. Distribute. As a reminder, right, this law is a power x to the y is equal to a to the power of x times y. Okay. So for our first term, the 3z squared x negative 6 y squared to the fifth, I will simply multiply each of these exponents in the inside by 5, right? So this is 3 to the first times 5, z to the second times 5, x negative 6 times 5, y squared, or y to the second times 5, right? And we can simplify that to 3 to the fifth, z to the 10th, x to negative 30, and y to the 10th. For the second term, we have y negative 3, x to the 12th, and z to the 5th, all of that cubed, right? So we're going to multiply all of these exponents by 3 instead. We get y negative 3 times 3, x to the 12 times 3, and z to the 5 times 3, right? This will give us y to the negative 9, x to the 36, and z to the 15th. I'm going to highlight the distributed exponent for clarity, right? Now that I have my two terms, right, my two simplified terms, I need to multiply them together. And for multiplication law, remember that I need two of the same base, right? Because it's a to the power x times a power y equals a to the power x plus y, right? So these are same base. So when I look at my two terms, right, I need to multiply the same bases by each other. I'll just write that out real quick. So 3 to the 5th, z to the 10th, x negative 30, y to the 10th, all that times y negative 9, x 36, z 15, right? So first off, I'm going to deal with the constants, right? Because when you write these sort of terms, we do constants first and then variables, right? That is by itself, and we get 243. Okay. And next up are the x's. So my two x's right here. I'll do a different color actually. Do I have enough colors for that? Let's hope. So you have x negative 30 plus 36. We'll use pink for the y's now. You have y 10 plus negative 9. And then brown for the z's. Z to the 10 plus 15, right? And now we can simplify this down to 243 x to the 6, y to the first, z to the 25th. Right. Now look at my answer, right? And I do not have any negative exponents. That means my answer is done. You can take away the one exponent, right? Because it's implied when you don't have the exponent that it's 1, but I'm going to leave it in there for visual clarity. Of course, on MPE, it's multiple choice, right? So when you look at an answer, it doesn't have the 1. Just remember that when something doesn't have an exponent, like explicitly declared, the exponent is a 1. By that I mean, if I say x, right, this is x to the first. If you're missing this exponent, it's going to be a 1. Okay. That is question 1. I should write in the answer box, right? 243 x to the 6, y first, z to 25. All right. So for the next couple questions, we need to factor. Okay, and no negative exponents. So I want to notice for number 2, right, is that I have my let me backtrack. So I have a quadratic, right? This is a quadratic equation, a second degree polynomial, if you will, right? Which means it's in the form of ax squared plus bx plus c, right? Note that this first, my a, right, is not 1. My a is not 1. I do not want to use quadratic formula. Even though it will give you the zeros, right? Using those zeros to create the factorization is a little awkward in my opinion. I'm just a better fan of butterfly method, where you find the two factors and then you split and you just factor from there. I will show that, of course, do not worry. Okay. So for a, it's not 1, right? I will avoid quadratic formula. All right. So what I'm gonna do first, right, is like I said, I want to find my two factors to split this, right? Because ideally, when we group, right, when we group things together, right, we have like 4 terms, right, and then we group these together, and then we get a solution of something times something, right? But I currently have 3 terms, right? I have 1, 2, 3. I need to split that middle term into 2 more terms so I can group, right? That's the whole basis on butterfly method, or whatever you want to call it. So let me erase that. Okay. So I'm looking for 2 numbers that do something. We need to multiply together for 4 times negative 15. Generally speaking, this is a times c, right? So if I go this way, we need to multiply together, okay? And here I just need b, and these 2 factors must add up to 4. Now, the reason this is the case, right, is when you make your factors, right, let's say, like a here and b here, right? You know that when you FOIL this out, right, you get x squared I know this is not entirely correct, but this is just for explaining, okay? X squared minus ax minus bx plus ab, right? It should be plus, right? Plus, 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 right? You had x squared plus a plus bx plus ab, right? So, see my two factors being multiplied and my two factors being added. But even if you don't understand why that's the case, just remember that this is the correct way to do it. So I'm going to list out my factors. So 160, 230, 310, 4, 15, 5 and 12, 6 and 10, right? If it's a really big number, prime factorization might be helpful, but 60 is small enough that I can list out all the factors quite safely, right? I do need negative 60, so when I look at these pairs, I know that one and exactly one of them has to be negative. For that reason, I'm going to choose this pair right here, because I know that I can use negative 6 and positive 10, right? Negative 6 times positive 10 is negative 60, but when you add them up, you get positive 4, which works. So now, I'm going to take my equation, or my expression rather, and split it up as I said. So my 6x plus 10x, right? If you add these together, you get 4x back, which is correct. Minus 15. And now all we have to do is to group each of these, right? So the left hand side, we're going to take a 2x. We have a 2x minus 3 remaining. On the right hand side, we can take out a 5. And we also have a 2x minus 3 remaining. You can see we have a common factor. You can take that out. And you're left with a 2x and plus 5. And that is your answer. 2x minus 3, 2x plus 5. Alright? Now, the third question, it doesn't look very approachable, right? I have these weird fractional exponents I have to deal with. But one thing I noticed, right, is that this exponent is exactly double of the other. Now, this is very important because this means I can do some substitution, right? So why is that? So note that for a quadratic, right? It's ax squared plus bx plus c, right? Now, the thing I want to know in particular is that I have a square, right? I don't necessarily need the 2. I need to look for something, right? The thing I'm looking for is that one exponent is double the other. Right, that's horrendous spelling. The other, okay? And if you notice, right, 2/3, right, is 2 times 1/3. So z 2/3, right, if I'm using my exponent laws, right, it is z 1/3 times 2, right, which is z 1/3 squared, right? So that means I can assign, like this value to be my x. So if I do this substitution, right, I say x equals z to the 1/3. This means x squared, right, is z to 2/3. So I can use substitution to create a proper quadratic. So I have x squared plus x minus 6. And this is much, much more manageable to solve, right? I have my square, I have my 1, right? Well, it fits the ax squared plus bx plus c, right? You could use quadratic formula. I personally wouldn't. I always use quadratic formula just for when I need to solve. I don't like it for factoring, but if you really have to, you can use quadratic formula. But I would not be showing that. Okay. Go. So sorry. So now that I have this equation, right? I can start a factor. So same method as before. I'm looking for two factors that multiply to a times c. So it'll be 1 times -6, so -6. And they add up to b, which is 1. This would be positive 3, -2. And you list out the factors. There's only so much you can do, right? So from this, I can rewrite my equation to x squared minus 2x plus 3x plus 6, right? Look at my left side, I can take an x, I get an x minus 2. Look at my right side, I can, wait, this is a -6, isn't it? It is. I can take out a positive 3, I get x minus 2. Common factor, x minus 2. Take that out, and then I have the x plus 3 remaining. But notice that my variables do not match, right? I start with z, but I have x. So I need to remember to substitute this back in, right? So I'm going to substitute my answer back in, my x back, my z back in through x, right? So z 1/3. Wait, no. Z 1/3 minus 2, z 1/3 plus 3. And that is my answer. So if you ever see a free term polynomial, right, and the x, or that's the degree of one is double the other, right, you can use substitution to kind of force or create an actual quadratic equation, right? So you can use the butterfly method, and your factor is a factor. But don't forget that when you substitute, right, you have a different variable from the start. So you have to substitute the variable back in to get the correct answer. So I said the answer is z to the 1/3 minus 2 times z to the 1/3 plus 3. Okay. All right. Number 4. Oh, this is good. Number 4. I'm to factor, right? So here we're not gonna use any like this type of find the factors using butterfly method, right? We have a sum of two terms, right? This one right here and this one right here. And so the strategy would be to find common factors, right? And take them out and then simplify. I don't usually do this for my own work, but for the sake of clarity, I'm just gonna write it out. All right, so term 1, term 2. And then I'm going to do my GCF, right? Greatest common factor. So I'm going to go ahead and write out some of these terms, okay? 7 minus x 3/4. Okay, I'm going to use colors real quick. Take this. Black and black. Okay, so I want to find stuff I can take out, right? But if I want to take stuff out, I have to share something common, right? So first you have your constants. Okay, so 6 and 8 will be my first two factors to consider. The greatest common factor would be 2, right? Now I deal with the x's, these lonely x's. So it'd be x squared and x. Greatest common factor would be x for me, okay? And you have the 7 minus x, right? It also has it over here, so that's good. So 7 minus x cubed and 7 minus, oh, sorry, not cubed, 3/4. And 7 minus x negative 1/4, okay? In this case, you could choose either or, right? It depends on what you're comfortable with. But I actually think I will take out the negative 1/4. All right. And then for my next term, this 2x plus 5, it's also here. So 2x plus 5, I think it's negative 7, right? And then 2x plus 5, negative 6. And I will take out a 2x plus 5, negative 7. Okay. So usually I choose the smaller exponent. Especially with negatives, it helps minimize how many negatives I have, but it's up to you, okay? Just make sure that when you're choosing a factor, that one makes sense. Like it actually is a factor for both, and two, when you're going to draw it out, that you do it correctly. Okay. So I have this in mind. That means my factor on the outside, right, would be 2x times 7 minus x negative 1/4 and 2x plus 5 negative 7, right? So I'm gonna keep this to the side because I need space for taking this factor out, right? Because I want to take this factor out of both terms. So for term 1, right? So I have the 6 divided by 2, right? And this gives me 3. Okay. Actually, let me move this down a bit. My x squared over x gives me just x, right? My, let's see, 7, that's the wrong color. Sorry, give me a second. My brain is not functioning. All right, 7 minus x to 3/4, right? Over 7 minus x negative 1/4. And by the way, I'm writing it out just for clarity. You can, save yourself some time and just write it out. But 7 minus x, and by the division law, right, is 3/4 minus negative 1/4, which gives me 1, right? So this is just 7 minus x. And finally, 2x plus 5 to the negative 7, right? Over 2x plus 5 to the negative 7, just 1. So this yields me a final term of 3x times 7 minus x times 1. Okay. Now for term 2, same process. 8 divided by 2 equals 4. X divided by x gives me 1. 7 minus x to negative 1/4. That's not, whoa, that's horrendous. Negative 1/4, I'm zooming a bit for y'all. Over 7 minus x to negative 1/4. I keep forgetting to write the 1. This is just 1, right? And then 2x plus 5, negative 6 over 2x plus 5 negative 7 is 2x plus 5 negative 6 minus negative 7, which gives me positive 1, which means it is just 2x plus 5. All right. Let me do an arrow. Okay. And this yields me 4 times 2x plus 5. Okay. And that means next to my common factor, right, I will get 3x times, actually, let's, this way. So that means for my terms, right, it will be, I need more space, so I'll move this down a bit. Okay. Be 3x, 7 minus x, plus 4 times 2x plus 5. Okay. And if we look at strictly this expression here, right, we can distribute these, right? So we get, sorry I'm talking kind of robotic-y. My brain's working, it's just hard for me to talk at the same time. So we get 21x, right, minus 3x squared plus 8x plus 20. Combine like terms, you get negative 3x squared plus 29x plus 20. Okay. Perfect. Yeah. So with this, right, we can now try to factor this out. Because we have to fully factor this, right? So I need to see if I can even try to factor this out. So, all right, let's just try butterfly method, right? Boop, boop. So two numbers that multiply to negative 60, negative 3 times 20, right? And add up to 29, okay? So we have some options. Well, let's see if any options, right? So let's set the factors. And none of these look very promising, at least to my eye. I believe this is a prime number. Oh, it's not prime number, sorry, prime polynomial. I cannot figure out how to get 29, right? That gives me 28, which is close but not quite there. Yeah, so I cannot factor this, right? There's nothing I can choose that gives me 29 when I add them up. So my final answer, right, will just be 2x 7 minus x to negative 1/4 times 2x plus 5 negative 7 times negative 3x squared plus 29x plus 20. Okay. This question does take a while. It took me a while because I'm just explaining all the steps, but just make sure that all your steps are correct. That sounds rather useless advice, right? I was like, how do you do this question? Do it correctly. But these type of questions have a lot of steps to them, and with a multiple choice exam, right, the other wrong answer choices tend to have an answer that will exist only if you mess up somewhere. So be very, very careful when you're doing these large type of questions. And okay, the answer key, I actually did not factor the same way as the professor did, so I'm not even too sure if this is correct, but looks correct enough, so I'm gonna go with this. All right. So moving on to question 5. So I'm solving, right? Not factoring. I'm solving for the following equation. And if I can factor, I need to show the completely factored form, okay, of the equation to receive credit. Basically, this means show your work, okay? So the first thing when I'm solving, right, is I want to 1 either set to 0, right? Set to 0 and factor, or I'll put an or right here, right? Or I isolate the variable. Okay. Setting to 0 is very handy when you have like a one term, like a fraction equals 0, right? Or you can simplify to one term equals 0. Isolating the variable is very handy when um, setting it equal to 0 looks really awkward. Like when you have those questions with a ton of variables, right? I'm trying to think of an example. It's like in your daily packet. One of the yeah, I won't waste your time, but um, it's that sort of thing where you see the question, you kind of know whether you should be factoring or where you should be isolating, right? Um, looking at this, right? I'm definitely going to be factoring, right? I already have it set to 0, right? And I have what looks to be two quadratics on top and bottom, right? So this is a factoring problem. Okay. So first things first is I actually like to get rid of any um, constant factors. And I say constant because you never ever want to get rid of a variable, the variable you're solving for. Because I'm solving for x, right? You never want to divide by x and get rid of it. What I mean by that is that if like um x squared equals x, right? I do not want to divide both sides by x and get x equals 1, right? What I want to do instead is move the x over and then factor and get my two results, which is x equals 1, x equals 0, right? So be very, very careful when you're solving not to get rid of any instances that include the variable you're solving for, okay? Okay, so my top, let's start with top first, okay? Factoring the top, it's 2x squared minus 10x plus 12, right? And I can factor that with 2, so I'll get 2 times x squared minus 5x plus 6, okay? With my inside polynomial, right, I can factor that. Looking for two numbers that multiply up to 1 times 6, so 6, and add up to b, negative 5. This would be negative 2 and negative 3, right? So I will get 2 times x. Oh, actually, let me just focus on the inside, right? So this yields x squared minus 2x minus 3x plus 6. We'll zoom in again. Okay. And let me think. Sorry. Okay, now we group, right? Left side, to get an x minus 2 remaining. Right side. So I want a negative inside, right? That means I want to take out not a positive 3, but a negative 3 to ensure that I have an x minus 2. Okay. Common factor, let's take that out. And we are left with x minus 3. So my numerator, right, is all of this times 2. Right, and this 2 comes back right here. And now for the second part, my denominator, right? I have x squared plus 5x minus 14. With the multiply method, I want two numbers that multiply up to 1 times negative 14, which is negative 14, and they add up to 5. This would be negative 7. Oh no, negative 7. Positive 7 and negative 2, alright? Means I can rewrite this as x squared. Okay, I'm writing small ones ago. X squared. Let's do negative 2x here. So I compare this plus 7x with a 14, alright? Left side, take an x minus 2. Right side, take out a positive 7, x minus 2. Common factor, take that out. You're left with x plus 7. Okay. And that is actually my factorization, right? So when I combine these together, right? So this is my numerator, this is my denominator, right? When I rewrite the fraction, how do I want to do this? Break this arrow. Okay. I have 2 x minus 2 x minus 3 over x minus 2 x plus 7. Okay. Now first, oh, this is also 0. So first thing first is I need to look at restrictions, right? So my restrictions is any x value where the denominator is 0, right? So that means x minus 2 equals 0, x plus 7 equals 0. And this gives me that x equals 2 and x equals negative 7 are restrictions, okay? But for my solutions, I'm trying a different color, right? For my, oh wait, why did I use pink? I should be using red. Okay, for my solutions, right? I need to set my numerator to 0. That 2 doesn't really mean much, but I need that x minus 2 equals 0, and x minus 3 equals 0. And this leads to, oh, x equals 2, x equals 3. Now, you will note that, oh, this and this, right? It's both a solution and a restriction. And in this case, the restriction wins, right? The restriction overrides every time. So these don't matter, right? X equal 2 will not matter because of the restriction, right? So this is restricted, right? So my only answer is x equals 3. You will note that they don't ask for restrictions, so I didn't list it in my answer. But that would be my answer. I guess I would take one more step, right? If I want to fully factor this, I could take one more step, and I'm gonna draw an arrow with brown. Okay. Sorry for all the arrows. Okay. So, whoa, English. So with this, right? You know that the x minus 2 is on top and bottom. So my fully factored form is actually 2 times x minus 3 over x plus 7 equals 0. Alright. That would be your fully factored version, I believe, because you would like to cancel out the top and bottom terms. And then I should write that fully factored. But if you're solving for, restrictions, right, like holes, do not forget about that x minus 2, okay? That is question 5. All right, so, excuse me. problem 6 asks us to simplify and provide restricted values. And again, I can only use positive exponents. This one looks a little scary, but do it step by step. It's actually not too bad. Okay. So first things first is I want to make sure that there's nothing I can factor out right away. Okay. What I mean by that, I mean I don't want to factor out the x's, right? Because that might complicate my question more. But if there's any non-x values I can take out, I'll do that right away. Okay. So I notice that just a y on top, right? So I can take out the y from both terms, top and bottom, right here, right? And I can have y, we have x negative 4 minus x negative 3 over x negative 6 minus x negative 4. Now, this y is a constant, right? This is a constant factor. So what I can do is actually isolate the entire fraction by itself. So I'm going to write y on the outside like this. And then my fraction. X negative 4, 4, x negative 3 over x negative 6 minus x negative 4. This way, right, I can deal with just a fraction and not worry about the y interfering, right? But if you multiply these together, right, this y, this is like y over 1, right, will go on top and give me, this fraction back again, right? Or rather, the original, okay? So now I have this, I can isolate my fraction. So I just need to isolate this fraction right now, right? And this is what I will be working with. But with this in mind, I need to not forget about the y when I finish solving this simplification. Okay. So first things first is that I want to do my negatives. And now note that there's minus signs, right? I cannot use the law here to flip, right? This law. I cannot use this. This is a big note, right? Cannot do. So the only way to deal with this is to actually deal with each exponent individually. And by that, I mean I have to flip each of those x terms. So I have 1 over to entire fraction at once, right? I have to use this law on each individual term. Let me say it, okay? So I have 1 over x to the 4th. Sorry, that lasts like 20 seconds. It's confusing. What I mean is that you cannot flip the numerator and denominator instantly, right? You cannot do x to the 6 plus x to the 4 over x to the 4. Oh, sorry, it should be minus, right? Minus x cubed, right? This is a no-no. Okay. Anyways, back on track. Over minus 1x cubed and 1x to the 6 minus 1 over x to the 4. Okay. Now we have this, right? I need to create a common denominator, right? And the easiest way is to make the denominator equal to the largest possible power, right? Because if we're the same base, right? I have the same base. So I can just use the largest power for numerator and the denominator. So numerator, the highest power is 4, right? This x to the 4 I'll keep the same. But to raise this denominator to 4, right, I need another x, right? This 3 is so not doing it for me. And to make sure it stays the same, right, in value, I need to multiply the top by the same thing, right? because this fraction essentially equals 1. And multiplying by 1 never changes the value. In this case, it will only change how it looks, okay? This is all over x to the 6, and in the denominator, right, x to the 6 is the highest power, so I'll keep that the same, over 1 over x to the 4. Now, for the bottom, I need x squared, but on top, I'll also need that x squared to make sure that I multiply by 1, alright? With this in mind, I'll simply, actually, I'm just keep going down, okay? I have 1 over x to the 4th minus x over x to the 4th over 1 over x to the 6th minus x squared over x to the 6th. We combine these fractions, 1 minus x over x to the 4th, and 1 minus x squared over x to the 6th. Okay. So I need to multiply top and bottom by something to get rid of that denominator, right? So what I'm going to do is that I'm going to multiply the top by x to the 6th. This x to the 6th is the first, right? So what will happen is that these two values will cancel, and I'm only left with this value because my denominators are 1, right? But if I am going to do that, I need to do the same on top, right? Again, I need to multiply by 1, and same on top and bottom. So this whole thing is 1, right? This whole fraction is equal to 1, right? So when I solve this, right, I get 1 minus x, right, times x to the 6 over x to the 4. Why am my pen get so much thicker? 1 minus x times x to the 6, parentheses, over x to the 4, right, over 1 minus x squared times x to the 6 over x to the 6. And when I simplify this, right, this goes away, and this becomes an x squared. These two just go away entirely, right? So I get 1 minus x over 1 minus x squared. Going from here, this is difference of squares, right? So 1 minus x over 1 minus x, 1 plus x. Wait, I am missing something, aren't I? Right, the x squared, that's what I'm missing. The x squared, right? X squared, there we go, right? Now from here, right, we can take out these common factor, right? And notice I said factor, right? And I have x squared over 1 plus x. Well, I'm not done, right? Because at the very beginning, what did I do? I still have my y to deal with, right? So I'm put that y in, and this becomes x squared y over 1 plus x. And that is your answer. Actually, not yet, sorry. X squared y over 1 plus x. But now, I have to provide restricted values. There are quite a few. It's not too much, okay? So the main one you see, right, is that x cannot be 0, right? If you look at any of these denominators, right, it just can't be 0, right? Regardless of this exponent, right, x to the something being 0, right, that's just x equals 0, right? So x equals 0, right, this is one restriction. So this is a restricted value, right? Now, another thing to note is both of these down here, right? 1 minus x equals 0. This is x equals 1. 1 plus x equals 0. This is x equals -1. And these are both also restrictions. Right? These are restrictions that appear in my answer, right? So my restrictions would be x cannot be 0, x cannot be 1, x cannot be -1, right? Well, the final answer doesn't necessarily have 0 or 1, right? -1 is there are problems for this, right? And we can double check, right? 0, -6 minus 0, -4, right? This is 0 minus 0, 0. So this is a no, right? 1, -6 minus 1, -4, right? This is 1 over 1 to the 6 minus 1 over 1 to the 4, which is 1 over 1 minus 1 over 1, which is 0, right? -1 to the -6 minus -1 to the -4. This is 1 over -1 to the 6 minus 1 over -1 to the 4th, which again gives you 0. Okay? So this is my full answer right here. All of this. All right? All right. Question 7 says to solve for x. Okay. If you ever note that your variable is in the exponent, and the exponent only, right? You need to use the law where the a to the b equals a to the c means b equals c, okay? But what does this mean? What does this mean, right? This means I need to make bases the same. Okay. So if I look at this, right, I have a 5 as one base and a 120 and a 25 on here, right? So what I'm gonna do is, okay, I'm gonna write it out here so I can do my work. Okay, equals 1 over 25x. What I want to do, right, is I want to bring this up to the numerator because this is like 5 over 1, right? But this is in the numerator, but this is in the denominator, right? This is not gonna work. So I need to well, what's happening? I need to force this 25 into the numerator. The easiest way for me to do that, right, is to use the law where 1 over -ax is a to the x, right? Or rather, sorry, 1 to the ax equals a negative x, right? So going here to here, I get 5 4x minus x squared equals 25 negative x, okay? And now I have this 5 and a 25, right? The simplest base to use that's common to both would be 5. So this 5 stays the same. I should write this out. Common base is 5, okay? So my left side stays the same. My left side, though, 25 is 5 squared, so I'm going to do parentheses 5 squared power negative x. Now, from here to here, right, I need to use the multiplication law. A power x to power y is a power xy, right? So I get 5 4x minus x squared equals 5 to the power of negative 2x. And now I can finally use my law up here, right? This law, and I will get. Let me. Sorry, I just need to do some colors just for your sake. 5 squared, right? And then doing a law gives me negative 2x, right? Now when I take the exponents, right, I get 4x minus x squared equals negative 2x. I prefer a positive x squared, right? I prefer positive leading term, so I'm gonna move this side over here, and I'm gonna get 0 equals x squared minus 4x minus 2x, right? Actually, I'm gonna use black actually. So move this over here. I get this, right? And now I can. Sorry, I'm very indecisive sometimes. X squared minus 4x, okay? And now I can just simplify down this to 0 equals x squared minus 6x. And then when you factor it, put an arrow right here, okay? 0 equals x times x minus 6. And this you do x minus 6 equals 0, so x equals 6. And then x equals 0, so x equals 0. Okay? If you look at the denominator, right, this is my only chance of restriction. But 25x equals 0 is actually no solution. So there's no solution for x. Or, DNE does not exist, right? So this means I have no restriction. And that means both of these answers are my answers. So x equals curly bracket 0 comma 6. Curly means a set, so not a point, so this is perfectly fine. All right. Okay. Problem 8. We have these, laws, these rules given to us. Okay. And it says use the rule of exponents to solve for x in terms of r and w. What this means is that when I'm simplifying, right, I need to rewrite numbers to be in terms of 3 and 5 only. So for example, right, if I had what's a good one? Like 9, right? So 9 would become 3 squared. 5 would become, not 5. 25, right, would become 5 squared. And those are just a couple examples, okay? But the point is, I want to only use 3 and 5 as my numbers whenever possible, okay? These are just examples. Okay. So with my 15x, right, my 15 of power x, right, I can rewrite that as 3 times 5, right? And my 8, I can rewrite that as 2 cubed, right? And the reason I'm using 2 here is because of one other thing I need to mention is that I also need to rewrite numbers to base 2. That means if I have 4, I should write 2 squared, okay? My exponent laws or rules of exponents, whatever you call it, all depend on one thing, that the base is the same, right? So I need to make sure everything is in base 2 to ensure that we're in business, okay? Now, what I'm going to do first is rewrite the 3 and 5 using the rules we have, right? So this would be 2 to the r, right, times 2 to the s, w, sorry, to the power of x, all that to the power of x equals 2 cubed. Now, first law, right? We can multiply these together, right? And get 2 times r plus w power of x equals 2 cubed. Now, I'm solving for x, right? So I actually do not need to distribute here. What I'm going to do is rewrite like this. 2 times r plus w times x, right, equals 2 cubed. I'm still using the law where, actually, let me do this. This is ax ay equals ax plus y, right? And then here to here, ax y equals axy. Oh, sorry, 1 second. Oop. Okay. So what I did, right, is I took this sum and treated it as one factor, right? I can distribute it, but I don't need to. So I want x by itself, okay? And now from here, I can use the rule that I am running out of colors. Red, okay. I can use the rule that when the base is the same and both values are equal, then the exponents must also be the same, right? So r plus w times x equals 3. And since I didn't distribute, right, I can just move this over here by dividing. So x equals 3 over r plus w. And that's it. That is your answer. Okay. All right. Question 9 is to factor if possible, otherwise write prime. Okay. So we have 4 terms, right? If we have 4 terms, and they're all unique, right? Like, I cannot combine these terms, right? So, cannot combine as is, right? So I have 4 unique terms, so try grouping. So first things first, right? So I'm going to rewrite my equation here so I can show you my work. So I prefer descending order. So I always write with descending power. So if you're out of order, I rewrite in descending order to make sure by degree, I suppose, okay, to clarify. This is to make sure that it just works better for my brain. I like if these two were switched, like if I wrote what was it? What's something that would throw me off quite a bit? Like plus 9 minus 18w minus w squared. This is really weird for me to factor. So I prefer to write everything in numerical order. And by numerical order, I mean the degrees are in numerical order. Highest degree at the left, the lowest on the right. Okay? So first, I'm looking at my left side, and I'm like, okay, I take out w squared. And I will get a 2w minus 1. Okay? I'm looking for 2w minus 1 somehow on the other side, right? So I'm going to opt for negative 9, actually. And now we get 2w minus 1 again, okay? Same factor, take that out. You're left with w squared minus 9. W squared is a perfect square, and so it's 9. So from here to here is actually difference of squares. Always be very wary if you have something squared minus another number. There is a chance that it's actually a difference of squares, okay? Or something squared minus something squared is definitely difference of squares, right? Like x squared minus y squared, that's x plus y, x minus y. Okay. Now, this is my answer. Right? Completely factored. 2w minus 1, w minus 3, w plus 3. That's it, right? So this exam was about an hour. Me talking for this whole thing, writing it down, explaining. I'm looking at my audio track. I'm at an hour, 5 minutes, right? So there's definitely a lot of time for you to do this, but do these questions, right? It was this exam was more of, did you recognize what game plan was supposed to be, right? Like for number 9, did you start grouping, and did you recognize the loss, like difference of squares that showed up for w squared minus 9? I think some people lost points because we didn't simplify this difference of squares, right? Um, Number 8, that's straight from your daily packet, that whole section with rewriting numbers in terms of something else, right? Number 7 was just application of exponent laws, right? This is a very common type of question you see where the variable is in your exponent, so you need to force both sides to have the same base, and you need to manipulate those exponent laws in your favor. Number 6, um, this is just more exponent laws and then simplifying fractions, right? This is actually mostly algebra. I only use an exponent law once, right? Which is to flip the x's over to avoid a negative exponent, right? And then restrictions, right? Making sure that you look through your work and make sure you get every single restriction and not just in the final answer, but also the initial step or the initial problem and your steps. All right. Number 5 is just a lot of factoring, right? Um, Nothing crazy there. Um, but also making sure that you solve for restrictions whenever you have a denominator, right? Um, Obviously, now at this point, you also know that logarithms have a restriction and radicals have a restriction, but I'll go over that in another video, right? Number 4 is just super tedious. You just gotta take out slowly each common factor and then simplify what you have remaining. Number 2, it's number 2. 2 is very simple, factoring very straightforward. Number 3 requires a little more finesse to do substitution to force a quadratic, to force the equation, or sorry, expression rather, to be in quadratic form. And then you need to not forget to substitute the substitute value back in. And number 1, that's just straight up exponent loss. Nothing crazy there. And that is it for this exam. Thank you for watching and listening.